Okay, so people watching on YouTube, this is a statics SARC session, or study union session. I'm going to be running through 6 problems that I think cover material you guys learned, and how we're going to do it. We're going to do the first 3, then we're going to do a 10-minute break, and then come back to the last 3, and then we'll end about 15 minutes early. So let's just start with number 1. So with number 1, they're asking us to determine the force in members BE, EF, and CB, and state if the members are in tension or compression. So to do this, we're going to make a cut. So we want to make this through those 3 members, BE, EF, and CB. So that would be like right here. Okay? That one lines up with that. Okay. So now let's draw this cut so we can see it better. Okay, so this is D, this is E. Oh, that's C. This is E. We have a 5 kilonewton going down, 5 kilonewton going there, and a 10. Okay, so then if we look at each of these, this is force CB, force BE, and this is force EF. Okay. So now let's do an analysis. Let's see what we got here. So first thing I'd do is, since both of these are going down, let's do sum of the forces in X to find this one, BE. So sum of the forces in X equals 0. Okay, so that gives us 5 plus 10 minus FBE. Now, we need to figure out what that angle is. But if we look at this shape here, it's 4 by 4. So essentially we have a 4 by 4 triangle. So we have a 45-degree angle. So this is going to be cosine 45. And that equals 0. Solving that just gives us FBE equals 21.2 kilonewtons, and that's going to be in tension. All right. That's tension because we got a positive value. And we drew them all in tension. Okay, so now we can move on to finding CB. Now, to find CB, we can't just do sum of the forces in Y because both of these are in the Y. But if we do the moment at one of these points, we could find the other one. This one, I think, would be the best one to do the moment at, since you have 3 forces acting on it, so it's essentially eliminating all 3 of those. So we're going to do the sum of the moments at E equals 0 in the counterclockwise direction. Okay, so all right, so because this is being live streamed, I'm going to have to ask that we be quiet, just because, so it doesn't pick up on the video, but you guys are fine. Okay, so since we're doing sum of the moments at E equals 0, we could have -5 times 4 because of this force, and since that's going clockwise, it's going to be a negative, and then we're going to have 4 FCB equals 0. So that's going to give us our force through CB is equal to 5 kilonewtons. Since that's positive, it's in tension. Okay? So now we can do sum of the forces in Y because we know all the unknowns. So sum of the forces in Y equals 0. So we get negative 21.2 sine 45, right, because that's BE. Then we have the 5 that we just found, the 5 acting on E, and then the force we're trying to find, FEF, and that all equals 0. So solving that gives us our FEF is going to be negative 25 kilonewtons. Since this is negative and we drew it in tension, that means this is going to be in compression. Right? Oh, and anybody who came in, there's evaluations on the back table if you want to grab them. Okay, so that ends the first part of this problem. So I'm just going to box that off. These are really two different problems that I just put together. Okay, so the second part is asking for the force in members BF, BG, and AB. State if the members are in tension or compression. So BF, BG, and AB. Now, if we did a cut through all three of those, we would also have to make a cut through EF to finish it off. So what we're actually going to do is make a cut through two of those, right there, and then we're going to solve for BF using method of joints. Does that make sense to everyone? Okay. So I'm just going to draw my figure now. Okay. So
isn't BF zero force member?
Exactly. That's why when we do method of joints, which I'll do in a second, you'll see that it's a zero force member because you'd have no other horizontal acting on it. Okay, so this is BG, and then this is going to be FG. This is F, this is B. We have the 10 kilonewton acting here. E. My picture's not very good. Okay. Let's see. Let's redraw that a bit. Okay. So we're going to have 5 kilonewton here. Okay. So now let's do method of joints at F. So our joint essentially looks like that. We have FE, FG, and BF. And since we're trying to find BF, all we're going to do is say sum of the forces in X at F is equal to 0. And that's just going to be negative FBF equals 0, so FBF equals 0. So it is a zero force member. Okay, so now we can move on to our section that we cut. So using our section, we're again going to find the one thing in the x direction, because I think that's the easiest to find. So let's do sum of the forces in x equals 0. So we have, let's see, we have the 5 at the top, plus the 10, plus the other 10, and then plus FBG. So since that's the same 4x4 angle, we're going to continue using 45 as our angle. So that's just going to give us our FBG is equal to negative 35.4 kilonewtons. And since that's negative, it is in compression. All right. Now, in order to find our last point, FAB, instead of finding this and then doing sum of the forces in y, let's just do sum of the moment about F. So if we do sum of the moment about F equals 0, and that's counterclockwise, we're going to get negative 5 times 8 up at the top, minus 10 times 4, plus FAB times 4, and then plus FBG sine 45 times 4, and that all equals 0. Right? So from there, we know FBG, we can just plug that in. So our FAB is going to equal 45 kilonewtons, and that's going to be in tension. Okay. And that is my first question. Make sense? All right. We'll move on to the next one. Since you guys weren't in here when I did the overview, basically what's going to happen is I'm going to do the first 3 in the first hour. And we're going to do a 10-minute break, and then we'll move on to the next 3. Okay. So number 2, just drawing a shear moment diagram. So for this is a pin, so we have an AY and an AX, and a roller, so this is going to be a BY. Okay. So to start these, we're just going to do the reactions. All right, support reactions. So sum of the moment at A equals 0. So let's do this. 0 is going to be negative 800 times 1 minus 1200, because that's the moment they gave us, minus 600 times 3 plus 4 BY. So from that, we can just solve for BY is going to be 950 newtons. Okay? So now since we have that, we can solve for AY by just doing sum of the forces in Y. 0. So AY minus 800 plus, minus 600. My bad. Plus BY equals 0. So I'm going to plug that in. So AY equals 450 newtons, right? And then sum of the forces in X, AX equals 0. Okay, so from there we can start our shear moment diagrams. So I'm just going to draw this directly under. Okay. So I'm just going to make those dashes at each distance just to help me see it better. Okay. So the shear at 1 is just going to be 450 newtons because that's our AY, right? So let me just write this out. So the shear from 0 to 1 is just 450 newtons. We jump up to 450. And then we have no shear acting on it till this point. Then it's going to be 450 minus 800. So that's going to get us to negative 350. Right? And then we have no shear acting on it until this point, where we have minus 600, which brings us down to negative 950. That looks bad. Let me rewrite that. And then no shear acting on it till here, where we have BY, which is 950. So that brings us all the way back up to 0. Did that make sense how I did that? them pretty quickly. Okay. So from here, we're going to do the moments. So I prefer method of integrals, so we're just going to do method of integrals. So moment from 0 to 1 is going to be the integral of this line. So this line is 450, right? B equals 450. So we're going to do integral 450, not 40, dx. So that's going to be 450, geez, 450 x plus c. Now our c is our initial moment. In this case, that is 0. So that means our equation is just 450x. So now we're just going to plug in at 0. Well, at 0 we know it's going to be 0. And we're going to plug in 1. So plug in 1, so 450 times 1. So we're going to go up to 450 at 1. And this is just going to be a straight line from 0. All right? Okay, so from this point to this point, we're going to do the same thing. So m1 to 2 is just going to be the integral of negative 350 dx, which is negative 350 x plus c. And in this case, our c is going to be 450. My bad. Because that's where we're starting for on this line. So we're going to plug in, again, another 1. So m at 2 is going to be negative 350 times 1 plus 450, and that's just going to be 100. So we're going to go down to 100. And that's going to be another straight line because it's a linear equation. Okay. Now, because we have a clockwise moment given to us in this problem, that is actually going to produce a positive thing on the moment diagram instead of a negative. So we're going to add 1350. Sorry that it's kind of colliding with the shear diagram here. So 100 plus 1200 is going to be 1350, 1300. Yeesh. Okay, 1300. That's our new point. Does that make sense to everyone? You just add. This is a direct adding. Okay. Again, I'm just going to use the same equation, but our new c is going to be 1300. So moment 3 to 4 is negative 350 x plus 1300. And then I'm going to plug in 1 times 1 plus 1300. And that's going to give us 950. So that's our new point here. And then our last equation, moment from this was 2 to 3. 2 to 3. So this is 3 to 4 is going to be the integral negative 950 dx is negative 950 x plus c. And in this case, that c is 950. So moment at 4 is going to be negative 950 times 1 plus 950. Which is 0. That makes sense to everyone? It's not too bad. I just wanted to include one with a applied moment on it. Okay. So let's move on to 3. This one's a bit more wacky. Okay, so let's start this one out with the support reactions. So we know this load is going to have a concentrated load here, and it's going to be 1/2 base times height. So 1/2, 24 times 4. So we're going to have 48 kips acting at that point. Okay, and since this is a fixed beam, we're going to have an AY, an AX, and a moment at A. So now let's move to the support reactions. So let's start with the sum of the moments at A equals 0, since that eliminates this AY, and that's how we find our MA. So that's just going to give us, MA minus 48 times 12 equals 0, right? That's just this load. So MA is then equal 576 kips times foot. Okay, now we'll do sum of the forces in Y equals 0. So that's going to be AY minus 48 equals 0. So AY equals 48 kips. All right, so that's it for the reactions. Now let's move on to doing the shear moment. Okay, so what we're going to do is we're going to look at each section. So let's start with 0 less than or equal to x is less than or equal to 12. So what we're going to do integrals again. So we're going to look at the load first. The load is going to be negative 4 over 12x, right? Because it's the ratio, rise over run. And this basically, it's not an upwards triangle, it actually is a downwards triangle like that, right? In the load. Okay, so our load is going to be negative x over 3. So now we can do our integration. It's the integral of the load dx. Integral negative x over 3 dx. So that's going to be negative x squared over 6 plus c. So our c is going to be our AY, 48. Right? So let's draw my shear. So at the very beginning, we just go up to, 48 kips. So, sorry, this should be a V, not a W. That's why that's our C value, though. So now let's plug in at 0. It's going to be 48. And then V at 1 is just going to be negative 12 squared over 6 plus 48. And that equals 24. So we're going down to 24. Okay, so what does this look like? Well, we got to think. This is what this looks like. We're going to use that circle thing. PDNI. Please don't neglect infants, neglect dumb people instead. That thing. Okay. And we got to look at what's happening from 0 to 12. So this is going to be increasingly negative, right? It's getting more and more negative. So this is what our slope's going to look like. Okay? So now let's do the moment for this section while we're here, since we have the shear already. So that's going to be the integral negative x squared over 6 plus 48 dx. So that's going to be negative x cubed over 18 plus 48x plus c. In this case, our c will be our applied moment at A, 576, or our support reaction moment, not applied. So this becomes negative x cubed over 18 plus 48x. That would be minus 576. So since this is counterclockwise, and we're on the moment diagram, that's going to go down. That's why it's a negative 576. Okay? So from here to here, we just go straight down to 576. Okay? So now let's plug in 12. So negative 12 cubed over 18 plus 48 times 12 minus 576, and that's going to get us to negative 96. So we're going to negative 96. Now, since this was positive, right, it's above this axis, but it's decreasing, we're going to be doing this slope from here to here. Okay, so that's it for that section. Now we'll do from 12 is less than or equal to x is less than or equal to 24. This is where it gets a little weird. Just in the hard part here is to find what your load equation should be. Okay, so essentially, before our starting point was 0, but now we got to look at this. We're just looking at this line here of the load, right? So we got to find what this point is. So that's going to be our load at this point. So where was I? If this is your load equation, then we can plug in, so 1 to 2, or at 12, my bad, is going to be negative 12 over 3, which is going to be negative 4. So that is this point. So then our new equation for the load is going to be a positive slope of 4 over 12. So 4 over 12x, and then minus 4. Right? That's our slope. That's our y-intercept, basically. Just think y equals mx plus b. So that's just going to be x over 3 minus 4. So then our shear from there, now it's just simple integration again. So it's going to be the integral of the load dx. So that's going to be x over 3 minus 4. So that's going to be x squared over 6 minus 4x plus c. Now, in this case, our c is going to be this 24 that we left off with from the first part. So this is going to be x squared over 6 minus 4x plus 24. Okay. So from there we can just find our shear at the end, at 24. So again, we're just going to plug in 12 as the distance over 6 squared minus 4 times 12 plus 24, and that should equal 0. So we're going to end back here. Now let's think about what this slope should be. So this is negative, but it's becoming decreasingly negative, right? So it's going to be this ND. So it's going to look like that. Does that make sense? Okay. That's at 0. Okay, so now let's look at the moment. So the moment is going to be the integral of our shear, x squared over 6 minus 4x plus 24 dx. And that's going to be x cubed over 18 minus 2x squared plus 24x plus c. In this case, our c is that negative 96 that I forgot to write. So x cubed over 18 minus 2x squared plus 24x minus 96. And then we're just going to plug in 12 again to find the moment at 24. So that's going to be 12 cubed over 18 minus 2 times 12 squared plus 24 times 12 minus 96. And that equals 0. So let's look at what's happening in our shear. So this is positive decreasing. So it's again going to look, let me redraw this so that it looks more natural, because it's going to be like, if that makes any sense. They both have the same curve to it, but it doesn't look like, it's not completely disjointed in the actual picture. All right, does that make sense?
For the interval at the end, how you did it from 12 to 24, you could have done it from 0 to 12 as well, right?
So yes, it's basically what you're doing, because I'm plugging in 12,
Right.
I'm just doing the distance from here to here.
Oh, okay.
That's what I'm plugging in.
Okay.
So I don't really look at the limits so much. I just, plug in that distance.
Oh, okay.
All right. So we got a little bit of time before our break. So if anybody has any questions about the 3 that we did. Yeah.
Can you see the last bit of work on it?
Yes. Also, I don't know if everybody got the evaluations in the back of the room. I could grab them. You don't have to get up.
Oh, thank you.
Who else didn't get any? No problem.
So it'd be like plugging in 12 minus 0, which is 0. So you pretty much did for that. It just threw me off because you broke from 12. Yeah, either way, it's just finishing off. Yeah. Because that's true. It is from 12 to 22. Just the zone just makes it easier. It just threw me off. It's only just puts from 0 to whatever it is. Yeah. So it's all the same stuff.
So I'd say the probably the hardest part when I was trying to go through this, when I was doing it, was this load. It's just recognizing this line and knowing that's what the load should be, and that's what you're going to integrate. Because, you'd want to do basically the same thing that we did in the last part, but you got to be careful about it. All right. Does that make sense to everyone? We could, let's just take our 10-minute break right now, and then we'll be back at 10:15. All right, guys, we're gonna get back to doing the study union. So this link that I wrote at the top, I don't know if you guys know, all of these are posted on the WordPress, which is that you go there, go to engineering, and then just find me. There's a lot of all the different SI, SARC tutors, they all have their information put up there. I'm going to be putting up the answers to these, so what I'm writing down now, probably later tonight. Yeah.
Is it on ucfsarc.wordpress.com?
It's not on the SARC WordPress, it's just on the study union one. Yeah. Yeah. And then if you want to re-watch me do this exact thing, it will be on YouTube. It's being live streamed right now, so. Okay, so let's begin. We need to find x bar and y bar for this figure. So, start with x bar. So what we're going to do is use this formula. Okay. So I'm going to draw the picture of what this should look like, essentially. Maybe I should make this fatter. I'll make this a little fatter. Okay, that looks better. So our dx, this is the most important part, is, you know, figuring out what's the dx, what's the y. So we're trying to find dA. So we want this to be in terms of dx, since we're finding x bar. So this is going to be your dx. It's the sliver, the change in x. And then your y's are going to be this change in y. y2 minus y1. Does that make sense to everyone? This is dx, and that's your y's. So that makes this dA change into y2 minus y1 dx. So in problems where, you know, you don't have two lines there, it would just be y dx. But since we do have two, it's basically I think you do it in Calc 1, right? It's like the whole minus whole method, that whole thing. Similar. So that's how you find your dA. So from there, honestly, it's pretty straightforward. X bar is going to be our integral from 0 to 100 of x, y2 minus y1 dx over the integral from 0 to 100 of y2 minus y1 dx. So now we need to change these y's so that they're in terms of x, right? So that would make this 0 to 100 x times x. So that's going to be this top line, y equals x minus y equals 1 over 100 x squared. So this is going to be x minus 1 over 100 x squared dx. And then we're going to do the same thing on the bottom. X minus. Does that make sense? Now, I don't think any professors are doing a no calculator portion or anything like that. So you can just plug these integrals into the calculator. Save yourself a lot of time. Instead of, you know, just integrating it by hand and then plugging in the limits. So does everybody know how to plug those into the calculator? I will. Okay. I have a TI-84. I know TI-89 can also do it. It depends on how old your calculator is, how well it'll work. But essentially, what you'll do, here, let me pull this to the side, is go to Math, and then go either down to Integral, or just hit Math 9, and then there's an integral. So then you just plug in, so this would be 0 to 100. So this would be x minus, this would be x squared over 100. Okay, and then just make sure the parentheses match up. So I have 1, 2, 3, and then I have 1, 2, 3. Okay, and then this, just put in an x for dx, then compute. So that gives us our top integral is 8333.3. Okay? Now I'm going to do the same thing for my bottom integral. And I'm going to save some time and just copy that, and then just get rid of the x. Right? And that gives me my bottom integral. Did that make sense to everyone, how I did that? That will save you a lot of time on the test. So then we just divide. So x bar, so I'm going to take this and just do divide by the answer. And that's going to be 50. So that's your x bar. Does that make sense to everyone? Good. All right. So let's move on to y bar. So y bar, same formula, except now it's a y, dA, over integral dA. Okay. So let me draw this again for you guys. Oops, there we go. Okay. So our dy is just going to be the infinite small change in y, right? So that little sliver is dy, and then your x's are going to be just x2 minus x1. Very similar to the first one. So now our dA becomes x2 minus x1 dy. So now we need to look at each of our y values and change those so that it's x in terms of y. So the first one, y equals x, that's easy. So x equals y. Second one, y equals 1 over 100 x squared. So x squared equals 100y. And then x would equal, so square root of 100 is 10. So you get 10 square root y, right? Now we need to be careful about what our x2 and our x1 is. So we look at this. This is our x2. That's our x1. So 2 and 1. So then we just get y bar equals integral from 0 to 100 y 10 root y minus y dy all over integral 0 to 100 10 root y minus y dy. Okay. Does anyone know an even faster way to save time for this part? What is our denominator? is the same thing as the top one. It's the same thing as this. So this is going to be 1666.67 because it's just dA. So whether you're using your x's or your y's, it's going to be the same. And we can prove that. I mean, plug it into the calculator. Might as well do that. Okay, so can you guys see anything on the calculator? Did you see it before? Kinda? Good. Okay, so we're going to hit math 9 again. 0 to 100. And then we're going to have, we're still using x's now. So this is going to be 10 root x minus x dx. So that's going to be our top value. And for some reason, it takes a while to calculate. Yes. So we get 666.6, repeating. And then if I take the top one and get rid of an x, and we should get the same thing as the top denominator. And we do. So then let me take this value and divide it by our answer. That gives us 39.999, so 40 millimeters. Does that make sense? It's not too bad. The hard part is finding, you know, what the graphs should look like. What's your dx, what's your dy? That whole thing. Okay, moving on to 5. Okay. Okay. So this one, locate the center of gravity G. So x bar, y bar of the street light. Neglect the thickness of each segment. Mass per unit length of each segment is as follows. So that's an interesting thing they gave us in this problem is these rows. They're basically just, in order to find the mass, which we need for center of gravity, we need to multiply these by the length of each part. So we're going to have to find the length of each part as well. Okay, so this one we're just doing, you know, sum x times m over sum of m. And same thing for y bar. Sum of y m over sum of m. Right? That's just center of gravity. Okay, so basically what I'm going to do is I'm going to separate this into parts and make a big table. So I'm going to say this is 1, this is 2, this is 3, 4, 5, and then 6. I don't know why my circles got smaller and smaller, but that's the way it is. Okay, so basically we got to look at what we need for this problem. So let's see, 1, 2, 3, 4, 6. Okay, so basically what we need to find our centroid, or our x bar for each individual part, and our mass for each individual part, and our y bar for each individual part. So we're going to have x y the mass x times the mass and y times the mass. All right? Okay, so let's go from each segment and find where the centroid will be. So for this one, centroid's just in the middle there. Centroid's in the middle. This one, it's going to be, somewhere right there. I'll explain that one later. That one's in the middle, and that one's in the middle again. Okay, so for 1, does anyone know what x bar would be for 1? 0, right? That's just on the axis. Can we say the same thing for 2 and 3? Yep. Okay. What's y bar going to be for 1? It's going to be 2, right? It's halfway. Now for 2, what should it be? Yeah, 5.5. So that's going to be this 4 plus this 1.5. Okay, for 3, this is going to be 0.5 plus 7. So 7.5. Okay. The mass for these 3, I'll just do these 3 first. So that's going to be, from A to B, we have a row of 12. So 12 times the length, which the length is 4. So that's going to be 48. So then for the second part, we got a length of 3, row of 8. So 8 times 3, that's just going to be 24. Okay, then for 3, length of 1, and a row of 5. So 5 times 1, so that's going to be 5. Okay, I'm going to come back to 4. We'll do 5 and 6 because they're also easy. So 5, the x bar is going to be, so this is 0.5 plus 1. So this is going to be 1.5. And then for 6, that would be 1. This is 0.75. So 1.75 plus 1, so 2.75. Right? Okay. Now our y bar, they're both in line with each other on the y bar, but it should be just the total height. 4 plus 3 plus 1 plus 1. So that would be 9. Does that make sense to everyone? Okay. So now to find the mass. So this one, again, it's going to have a row of 5, length of 1, it's going to be 5. This one has a row of 2 and a length of 1.5, so it's going to have a mass of 3. Okay. So now we can move on to 4. I left this one out just because it was more difficult to think about. So 4, they basically gave us, this arc. Now, from the back of your book, they have a quarter circle arc, but it's facing the other way. And they give us that this x is 2r over pi, and this y is 2r over pi. So, since we're coming from this way, we need to find this distance to find the x. So that would just be 1 minus 2r over pi, because they give us our distance of 1. Does that make sense? So our x bar is going to be 1 minus 2r over pi, and then our y bar, 2r over pi. Okay.
Excuse me.
Yes?
I could hardly hear you because of that. Could you go over how you found?
How I found this?
Yeah.
Okay, so in the back of the statics textbook, there's a chart with all the centroids for each part, or for each different shape. And they give you something that looks like that, rather than this way. and it's got to be, they give you the centroid from that side. So we need to do the total distance minus that centroid to find our distance. Does that make sense? Okay. The other important thing to note, because I screwed up myself when I was doing this before, is this is not a section. It's not a quarter of a circle. It's a quarter circle arc. So it's just on the outside of it. It's not a section. They have completely different formulas. So I like worked through it with the wrong formula, and I was like, why is this not right? But that's why it wasn't right. So that's our x and our y. So from here, our radius is 1. So that means our x should be 1 minus 2 over pi, right? Now our y, since that's 2r over pi, we're going to add that to this total length up. So 8 plus 2 over pi. Does everyone understand how I got that? Okay, so now to find the mass. So we know our rho is 5, but what's our length going to be? Well, we know it's a quarter of a circle. So what would the length of a fourth of a circle be? Yeah, because it's going to be the circumference divided by 4, right? So that's going to be pi r over 2. Is that what you said? Yeah. Okay, cool. And since our radius is 1, we're going to have pi halves. So this is going to be 5 times pi halves, which is just 5 pi halves. Okay, now we can just do x times m. So these three are going to be 0. Y times m, so this is going to be 96, 132, 37.5. Now I kept these in terms of pi. You don't have to. You're going to get a decimal anyway, so you can just make these decimal. But I like to keep it clean. So when you multiply these, you get 5 pi halves minus 5 and 20 pi plus 5. Okay? This is going to be 7.5, 45, 8.25, and 27. So that's just, that's just plugging into your calculator. That's nothing too difficult. Now to find the centroid, we need the sum of these 3 columns. We need the sum of xm, m, and ym. So the sum of this, 92.854. The sum of this is 18.604. And the sum of this is 405.332. Okay. So from here we can just calculate our x bar and y bar. So that's going to be 18.604 divided by 92.854, and that's 0.2 meters. And then our y bar is just 405.332 divided by 92.854, and that's 4.37. Does that make sense to everyone? I think we're going to end up finishing way early. Does it make sense though? Okay, good. Good. Okay. well, I only have one more left. And it doesn't take very long. So let's get to it. So this one, we're supposed to find the beams Ix about the x-axis and Iy about the y-axis, right? So I'm just going to draw a picture of the cross-section, because that's all we care about, nothing else. So let me just draw this. Okay, so our x-axis is going straight through here, and our y-axis is here. Let me extend that a bit, just because we're right there. Okay, so that's y. Okay, I'm just going to write the, the scale of everything. So this is 100 from here to here. Here to here is 15. So they give us the base is 100, but they give us the length of each of these individual ones is 15. So that's going to make this 85. Right? Or, yeah, 85. Okay? And I'm also going to do this whole distance from here to here, just because that's going to be 170. Right, 85 times 2 is 170. Okay, this is, again, 15. And then this distance from here to here is going to be 10. Okay, so basically how we're going to do this. So to find Ix, we're just going to use that formula, the Ix plus not equal a dy squared, right? So what we're going to do, instead of doing this whole part, we're going to take it and split it up into 3, right? We're going to look for, so we're going to find the I of each part, and then we're going to also find the dy of each part and the area of each part. So this first part, centroid's right here, right? And then the second part, centroid's right here. Third part, centroid's right here. Everybody see that? They're pretty, straightforward centroids. So that's what this dy is. It's the distance from this x-axis to the centroid. So let's begin writing our equation. So the moment of inertia of a rectangle is just that 1/12 base height cubed, right? So let's start with this middle rectangle. So this is going to be 170 as your base, and then your height is 10. So 10 cubed. Now, I'm not going to even find the area of this, because what is our dy going to be? 0, right? Because it's on the x-axis. So this is 0 squared. That's gone. Now, let's do, here, let me label these. That's C1, this is C2, and this is C3. So this is going to be, we're going to do this part. So our base is going to be 15. And our height is 100. And our dy is 0 again. So that's gone. And then our last part, 1/12, base of 15, height of 100, and dy is 0. It's a pretty nice problem. Cuts out a lot. So, that's just plugging in from that point on. It's just finding This part isn't even that much difficult. It's just recognizing, oh, that's what that is. That's what that is. You know. So Ix plugging in is going to be 2514166.67 millimeters to the fourth, or 2.51 times 10 to the sixth millimeters to the fourth. Okay? And that is our answer for the first part. Second question is asking for IY. So a little bit more work. So this is going to be IY prime plus a dx squared, right? So again, we're just going to keep the same 1/12 base height cubed situation. So for this first part, it's going to be, again, 170 times 10 cubed plus a dx squared. So what is dx for the first part? That's 0 again. Okay, so that's gone. Now, let's look at the second part. So this one, it's going to be 1/12, 15 times 100 cubed. And then what's your dx going to be? It's for C2. So not 0, right? It's 92.5. So that's the distance from this centroid to here is going to be 92.5. Because this is 7.5 plus 85. Right? So now let's find the area. So that's just going to be 15 times 100 times 92.5 squared. Okay? Now, let's do the second part. Or the third part, I mean. So that's going to be 1/12, 15 times 100 cubed, plus 15 times 100, 92.5 squared. My gosh. Okay. And that's going to give us our IY is 29.8 times 10 to the 6th millimeters to the fourth. And then we're done. How could I have saved time on this step? Just multiply by 2. It's a symmetric shape, so it's going to be the same on either side. Does that make sense? On the notes I'm going to post, I did multiply by 2. So that is unfortunately our last question. We have a lot of time. Any questions?
I have a question, but it's not pertaining to this problem.
Yeah.
It's pertaining to something. It's a really quick question. I don't know.
Okay. What is it?
It has to do with the shear diagram or a moment diagram. For this one, that's the shear diagram.
Okay.
So I'm confused at this part. We're at 534. It goes down 300.
Okay.
But isn't that positive? Because counterclockwise, I thought it would jump up 300.
Oh, so that's what I was trying to emphasize. I put that in my problems when we did the shear moment, because I know a lot of people would get tricked up with that. So this one that I did, the second one, see, this has a clockwise moment. It's reversed when you're doing shear moment.
Okay.
So it's going to go the other way. So because this is clockwise, you have a jump of 1200.
Okay.
I also had that in question 3, we found our moment at A is 576, right? That's going to be positive, so it's counterclockwise. So when we start the moment, it goes down 576 immediately.
Oh, okay.
It's flipped.
So how about for shear?
For shear? What do you mean?
Like, because when you do the reactions, like I still assumed counterclockwise was positive, and I still got the for shear, and I still got the reactions right.
I mean, shear doesn't change.
Oh.
Shear's the same.
Oh.
It's just the moment that's, I don't know why. We just write it like that. Yeah. Yes? Please don't neglect infants, neglect dumb people instead. How do you use it? Yeah. Positive decreasing, negative increasing, negative decreasing, positive increasing. Does that make sense? I'd say the trickiest thing there is with the negatives. Because, what does negative decreasing mean? Think about it as decreasingly negative. It's not getting further down, it's getting less negative. So it's going closer to positive, actually. Does that make sense? Decreasingly negative.
So you look at your final answer, like your number, and then you compare that.
Basically, yeah.